Welcome back to our series on building MCP servers on the Internet computer. In our last video, we built a simple counter tool using API key authentication. Today, we're taking it a step further by implementing a more robust and user-centric security model, Oauth. This powerful standard allows your AI tools to securely act on behalf of users, enabling personalized and trusted interactions without you ever having to manage user passwords. By the end of this tutorial, you'll have a complete MCP server that uses Oauth for authentication. We will first configure the server with the necessary Oauth provider details during initialization. Next, use the SDK's built-in Oauth handler to automatically validate user tokens. Finally, implement a clock handler that provides a personalized response to the authenticated user. Let's get started. Unlike a simple static API key, Oauth requires configuration details about the identity provider. We handle this in the init function, which runs once when the canister is deployed. We define an init arg struct to hold all our configuration parameters, such as the metadata URL, resource, issuer, and audience. These values tell our server how to connect to the Oauth provider and validate its tokens. Inside the init function, which is marked with the @init attribute, we take these arguments and store them in a thread local static variable named args. This makes the configuration accessible to our HTTP request handlers later on. This initial setup is a crucial one-time step to link your MCP server with the chosen authentication service. Now let's look at how our server handles incoming HTTP requests. Just like before, we need two handlers, one for query calls and one for update calls. The HTTP request query function remains the same. It's our initial entry point that uses with upgrade to true to seamlessly transition incoming GET requests into state-modifying update calls, which is a requirement for MCP tool calls. The real magic happens in the HTTP request update function. Here, instead of manually checking for an API key, we use a dedicated method from our SDK, handle with Oauth. This powerful method takes two arguments, the incoming request and an Oauth config. We construct the Oauth config using the parameters we saved during initialization. The SDK now takes over, performing the entire complex Oauth validation flow for you. It fetches the JSON web key set, verifies the token's signature and claims, and ensures the request is from a legitimate authenticated user. If validation fails, it automatically returns the appropriate HTTP error. This declarative approach abstracts away the complexities of Oauth, allowing you to focus on your application logic. With authentication handled, we can implement our core logic. Every MCP server must implement the handler trait, which defines the getInfo, listTools, and callTool methods. For our clock handler, the getInfo method provides metadata, including instructions that this server can tell the current time. The listTools advertises our single tool tellTime. We provide its name, a description, and define its schema. Since this tool requires no input parameters, we use schema for type for empty object. The callTool method. Show the callTool implementation. The callTool method is where we see the direct benefit of using Oauth. When this method is called, the SDK passes a context object that has been populated with information from the validated user token. Here we access context.subject.unwrap. The subject field contains the unique identifier of the authenticated user extracted directly from their token. We then use this identity to create a personalized response telling the logged-in user the current time. The time itself is securely fetched from the Internet computer's own clock using ic.cdk.api.time. This demonstrates how you can perform actions on a user's behalf, creating a secure and personalized experience. And that's it. We've successfully built an MCP server on the Internet computer that uses Oauth for secure authentication. We learned how to configure the server with Oauth provider details at initialization, use the SDK's built-in Oauth handler to automatically validate user tokens, and access the authenticated user's identity in the callTool method to provide personalized functionality. This foundation unlocks the ability to create powerful, decentralized AI tools that can securely and transparently interact with users and their data across the web. Thanks for watching and happy building.